There we go. How's it going, everyone? I'm gonna do some more Sonic today. Let me open up everything that I've closed off. I had to close off everything for some reason, but let me open it all back up. Here's Emacs, and whoops, I've lost the window. There we go. And what do we have? Firefox usually. We'll use it later. And terminal. Cool. I've forgotten where we were up to, what we were doing. Oh, okay, we were doing collision detection, weren't we? Trying to do collision. Let me run it so I can see what we're up to. So is my audio a little bit too loud? Looks like it might be clipping a little bit. Awesome. Thanks for letting me know. Okay, so that's the collision. That's the collision chunk. So that's what we're colliding with at the moment. That's the chunk that we're colliding with, and what we're trying to do, what the next steps were, we're trying to figure out what's the 16 by 16 block that we're colliding with. That's the next step. Awesome. Cool. Good to know that the audio is good. Okay. So the next step is we've got the chunk that we're colliding with. Now we need to figure out what offset we are in this chunk, and then figure out which block we're colliding with. That's the goal. Then once we've got that, we can go even, well, actually we don't even have to go further than that, because collision is actually done in Sonic by the 16 by 16, what do you call it, 16 by 16 block. So if we know the 16 by 16 block, we know how high the level is meant to be, so we know like exactly what pixel Sonic is meant to be standing at. So if we figure out which 16 by 16 block, we can then, then we can figure out exactly which pixel it should be colliding with. So that's the goal. Cool, so we've got the chunk. Where have we got the chunk? Is that what I'm rendering as the chunk? Yeah, that's the chunk textures, chunk index. How are we getting the chunk index? Layout X, layout Y. Oh, here we go. Player position. Here we go. Yeah. Okay. Player position. So we divided it up and figured it out. Cool. Okay. So tells us what the chunk is. Now we need to figure out what offset in that chunk is. How can I do that? I'm going to print out the remainder of this division. I want to see the remainder. No, I haven't forgotten to feed the cat. She's just loud and annoying all the time. It's just who she is. Yes. Hang on. Alright. Come here. Go on. Go on. There we go. Alright. So that's, what's this now? This is the remainder of dividing. Okay. So that's the remainder, which is probably the offset into this, is it? So 96 is what we are in X, and Y. Are we 15 pixels down? Maybe we're 15 pixels down? Could be. 15 seems like not enough. 15 down. It could be though. Because hang on, what do we actually start off as? What do we start off as? I'll print out the starting position as well. can't remember what Y position we're meant to start off as. Oh, that's the actual raw starting position. I need to, like, once I start, you know, moving things out of just one file, I'll be able to know this sort of stuff. Player start is what I want. Player start. Okay, so I want to see what Y position we're starting off as, and I just want to divide it by, what is it? Oh, x80, which is 128 in decimal. So 655, and yeah, 655, the remainder after dividing by 128 is 15. Because that's 640 plus 15, yeah. Cool. Okay, so that does tell us exactly which pixel we're at in this chunk that's getting rendered. So now that we've got the offset into the chunk, we should be able to figure out which block which block Sonic is colliding with. So we need to go 96 across and 15 down and figure out which block that's in. So there should be a block there somewhere that he's in. Cool. Okay, so now that we've got that, we actually need to we got the remainder of 128. We also need to divide it by 16, right? We need to divide by 16. I think we do. I think we do. Oh, sorry, that's not 16 at all. That is 10. What's 16? 10. There we go. Sorry, I'm getting that flipped. So that should be 16, right? I'm always bad with my hex. That should be 16. Cool. So that should tell us which block across. So it should say, what, 4 across? No. A lot more than that. It should be 6 across. Okay, 6 across and 0 down. So it's this one here, I guess, that Sonic is colliding with. 6 across? Somewhere there. How's it going? Okay, so that should tell us the X and Y position that we're colliding with. So that should be the block. So we've got the layout, and that gives us the chunk index. So we've got the chunk index, and we've got this chunk here, but we've got the chunk textures, but we don't want the textures, we want the chunk blocks. There we go, chunk blocks. Still working on collisions? Yes, we are. I want to get out the block that we're colliding with and render that instead of we got the chunk textures, but I want to render out the block. So I've got chunk blocks, and I forgot how to index into this one. That'll just be layout X. So that's the remainder after getting 80. Oh, hang on, we've already divided by 80. Oh, okay, we do need to do something like that then. I forgot why we added this, why we're adding that on. I guess that's where Sonic actually is standing on. I'm not sure. I've forgotten why we've done that. Whoops. So this is block X and block Y, and we need to index into this at block X, block Y. I don't know if this is actually how we need to index into this thing, but I want to print out the block index now. Now, what is chunk blocks? It's a list of list, and I've got a bounded array. Okay. Show chunk block. Using blocks. Where have I defined that? There we go. Do I actually want to show it? I might not want to actually show it. Let me get rid of this debug. And here we go. So I've got bounded array word 8 chunk block. Yeah, so I don't really want to show it. Yeah, this is if it's flipped or not. Actually, no, this is actually fine to show. Yeah. This is Spacemax, yeah. I've been using Spacemax for a couple of years now. So I added a show instance. I was a little bit unsure if I should add a show instance for a chunk block, but it's fine. Chunk block is just basically it's just an index and then whether you should flip x and y. So x and y is not flipped and the chunk block is 0. So I'm guessing here it's because we're kind of standing in the we're standing here, so it's basically the sky. So I guess that's chunk block 0. Let me just move Sonic down a little bit. Actually, I don't know if we need that if we had that plus 13 here. If we copy this back down, maybe we need this. Might need that. We'll see. What are reasons not to add a show instance? I don't know. I just before I thought maybe I shouldn't add a show instance because it was a big array, and I didn't actually like. Maybe it was better to have an error instead of actually trying to show a massive array. So that was my reason of thinking maybe I shouldn't have a show instance. Actually, I think I've flipped this around actually, isn't it? Yeah, I have flipped it around. I think I have to index y first and then x. That's what I flipped. If I had more types in this, I'd be able to know that. I'd be able to know that I'm meant to be indexing. You know, the answer is always more types. So that's what I should have been doing. But it still says 0. Still says 0 there. Alright. I'm not sure why it's saying... It should be saying... I feel like it should be saying not 0. Because the first chunk, I know the first chunk in this, I'm pretty sure is sky. So I have a feeling that's 0. Like if we actually run the game, if we see where Sonic is, he's standing pretty much on the ground. So he should actually be colliding with like a clown chunk. Sorry, a ground block. Should basically be colliding with this. So he should basically be colliding like that. That's what we should be getting. We should be saying, hey, this is the block. So seeing 0 doesn't. I'm not sure about that. But what we can do is, so we've got the chunk. So I'm gonna actually render the block 16 by 16, and we've got this block textures. Is that what I have to do? Can't do that? No, because it's a... Oh, can I do that? No, it's working. So I should see the chunk, and then we should see the block over here now. Should see a block. Yes, and so it's a sky block. So it's saying that we're there, I think. It doesn't seem right to me. Doesn't seem right. So we've got the chunk blocks, getting out the x and y. Let me make sure it is indexed by that. So a chunk block and chunk. So it's indexed by a word 8. How are we doing that then? Oh, we're getting the layout. I see. So we're getting the layout. We do y and x, yeah. So I think it is basically the same. So that should be roughly the index. I wonder what the problem is then. It just doesn't seem right. But if I move Sonic down a little bit more. So the start position, what was it? It was 640, no 655 and 96, 96x and 655y. So I'm gonna comment this out and just move him down slightly. So 96 across and what was it, 655 down. So I'm going to add him. I'm going to move him down even further. Move him down to 700 because then he'll definitely be in the ground and we should see something. Should definitely be in the ground somewhere. So if we go down and we scroll down, like I've got the collision map being rendered at the moment. Okay. So I've moved him down. You see he's actually in the ground now, so he should be somewhere around here. So that I would expect basically one of these tiles here. Instead we're getting flowers. So something's happening, but not the right thing. We're getting flowers. I feel like we should be getting one of these. Yeah, so we've got to figure out what's going on there. Yeah, I'm not sure where the flowers are coming from, but somewhere. Yeah, so we've got the start. So the block index is coming up as that. So I'm actually going to print out the chunk. Chunk index, right, so chunk index. So it'll tell us which chunk it is, but we want to see, what do I want to see? We should have the chunks up here somewhere. Chunk content. So this is the one where I was thinking maybe I shouldn't have a show instance, but I think I do want to see it because even though it's massive. Oh, not chunk content, it is chunk what? Chunk blocks. Is that right, chunk blocks? I think it's chunk blocks, yeah. Right. Oh, interesting. So chunk blocks. Is that right? Chunk blocks. Hang on. Chunk block gives me, yeah, chunk block. Okay. So I can index into a chunk block and get out chunk block. So I can index into a load chunk block. No, I want load chunk, which give me a chunk, and a chunk is, yeah, like the 128 by 128, cool, okay. And so I've got that, 128 by 128, yeah, but it's actually 16, how many is it, 16 by, no, it's 8. Yeah, there's 8 blocks across and 8 blocks down in a chunk. So that's what I should be referencing there, okay. So when I print it out, so I'm dividing by the right thing, I am, let me make sure I've got the right indexes into the chunk. I'm not sure about that. What have I got? So 6 across and 4 down. That seems about right. 4 down, somewhere around there, and 6 across is most of the way there. Like, so you know, because it's 8. There's 8 blocks. So I'm just thinking 6 across is like 6/8 of it, and then 4 is like half. So it should be about here somewhere, maybe. I'm not sure if... Oh, that might line up with what I see down here. Hang on, let me scroll down. Yeah, that's it. Yep, there you go. So Sonic is about there, below this image. And you can see, yeah, he's about there. Cool, so that should be showing something like that. So I think that's right. But when we have the... when we index into the chunk blocks and we get out that... block index. Yeah, so it just references the blocks. I think that's right. Like, I mean, it's, see how here we're referencing the blocks by the block index, and that's basically what we're doing down here. Is my index off? Block index? No, it's not. So I don't see the problem. Is the collision block the block behind Sonic or the one below him? The one behind him at the moment, I think. I think it's the one behind him. Should be the one like directly behind him, basically.
So I'm referencing the blocks with the block index, and that's what I am doing down here. So there should be nothing different. Yeah, I'm not sure. So the flowers don't come up for a while, so I don't know where the flowers are coming from. Don't know. Oh, but I need to reference. I'm going through all the chunk blocks, and I'm getting X and Y, but don't I need to dereference the chunk? Yeah. So I got the chunk blocks. But I need to figure out what blocks are in this chunk, so I haven't actually referenced that. So I've got all of the chunk blocks, and I need to reference just the chunk blocks for that chunk. Right, okay, so that's I think my problem. So I've got this chunk index. So actually I need to go layout chunks, don't I? So I've got the, where's the that's what I need to do. So I need to actually go through the layout. So I've got this layout chunk textures. Right, okay. So I've got a layout, where's layout? So a layout is a list of chunk indexes. So if I actually need to, but I know what chunk index I'm at, don't I? Because I've already got, yeah, I've got a chunk index here, so I already have referenced that. So then I need to go through, and what do I need to do? I've got the chunk blocks. So I've got the chunk blocks. Load chunks gives me a chunk. So I actually need to reference this chunk. How is this working at the moment then? Chunk blocks. I'm not even sure how this is compiling actually. So I've got chunk blocks, which is a load chunks of chunk content. So I should get a bounded array. But somehow I am using chunk blocks down here as an array and not a bounded array. Does that make some sense? I'm using it as an array and not a bounded array. So how's that working? Chunk blocks. I'm going to see what the type is by doing this trick. So I'm going to say, what is chunk blocks? Now I should expect it to be right. So it is a bounded array. Okay. It is a bounded array of chunks. Okay. That's what I'm doing wrong. So I'm using it as an X and Y. I'm using it as an indexed into a block, but it's not a block. It gives me back something else. So the type of this is it's a chunk block. Cool. No, expected chunk block, and it actually is a bounded array of chunk blocks. Okay. So I actually I think I need to actually reference this as chunk index. So I've got this, cool. So that is actually my my chunk index. So that will actually give me my now it should be like a list of chunk blocks. Yeah, sorry, I do have a GitHub repository bounded array. That's what yeah, I made it up. Bounded array is basically a safe version of array. So you can't index it. So if you've got like everything has to be filled inside of the array. So if you've got an array indexed by word 8, so if you've got, oops. If I have a bounded array of word 8, any word 8 is valid
to index into this, so I can always index into this f thing. I mean, I'll put it as empty as for now, but I can always index into this as long, like for every word 8, no matter what word 8 I use, I can index into this. So I can use 255, I can use 0, or anything in here I can index into it. So I'll always get an int for whatever thing can be indexed into it. So it's unlike array, where if you try and index into something that's not defined. So if I just use a normal array and I only had 10 elements in this, and I tried to access the 11th one, or if I tried to access the 11th one, it would crash, which can be pretty bad. You can actually get segfaults if you use arrays like that. So so mine, so instead of segfaulting, they've got all these checks and stuff to make array a little bit slower. My bounded array actually goes a little bit faster because I can get rid of all those checks, because I always know everything's filled inside of it. The invariance of my data type is that everything's always filled. So mine actually goes a little bit faster in indexing. So there actually is a benefit to the bounded array, other than it doesn't crash. Okay, so we've got chunk block. So I've got array of chunk block, and so now I need to figure out how that corresponds to, how that corresponds to a block. So if I get out the first one, that'll be the first one. So I need to figure out how do I index into that, and it should be like should be x multiplied by, no, it should be y multiplied by 16. I think this is how it should be indexed. Block y multiplied by 16 plus block x, something like that. Maybe that'll work. Let's see. No. Give something. It does give something. I'm not sure what though. $70. Don't think that's, it's not multiplied by 10, is it? Because it's only 8 by 8. So it's actually y divided by, y times 8. So that'll be a bit better. I realize that 70 is a lot. It's not quite right, is it? Because that's a lot. Okay, 38. 38. There's up to 64 of them, because there's 8 by 8. I'm not saying the 38th. Well, it's not actually the 38th because it's an index, so it's the 39th. It's the 39th image in that index. So I'm going to print out that block as well. I'm going to print out this block and we'll see what it looks like. See what this looks like. Okay, it's kind of hard to see what's happening there, but let's quit out of that and we'll see. I haven't got too much running. Okay, I just want to scroll up a little bit, and I should be able to see, whoops, close that off. So I'm looking what this looks like. 0, 0, 0, 0, then you start getting things. So this is the index, so it's an integral index, 21, 28, 36, and what was our index? Our index was 38, wasn't it? 38. Chunk block 16. Okay, so it should be getting out 16. Let me just confirm. Let me confirm that this says 16. Yeah, it should say 16. I can scroll up. Actually, this is Kitty terminal. Like, this is another terminal, and I can actually scroll up. It's just I don't know. It's just easier with tmux. Actually, it's actually just easier with when I use tmux. Interesting. So even though I'm indexing into this with what I think is the right thing. Oh, hang on. Yeah, what I think is the right thing. So block index. Oh no, hang on. Yeah. Wait, I've confused myself already. So what was I printing? I was printing out the okay. Try again. Oh, maybe this is xterm. I don't think it's xterm. I thought I was using a different. Interesting. I don't know what terminal this is. It might be xterm. Now that I'm looking at it. That's actually a good question. Oh, here we go. I fixed up the actual printing of my index, but I actually didn't fix up the oh, I see, the term variable. Yeah. I had to set it up because the color, to get color properly. Yeah, sorry about that. Yeah, I probably should put it in, I don't know, somewhere. There we go. We're getting something now. That looks better. It does look better because that is actually the right thing, isn't it? That is basically where we are. So if I get rid of, cool. Okay, we got there in the end. We got there. All right. The problem was I was printing. I don't know if anyone noticed, but I was printing out the correct index, but I forgot to update the actual code to reference the, to actually have the right index. So yeah. So I was just printing it out and I wasn't actually using it. So hopefully now we should see where Sonic should be standing. This is where I loaded up the actual starting position from Sonic, and so this is where Sonic should be standing when he starts up this level. And yeah, there you go. We've got it. That is, well, somewhere. Well, I guess it's there. It's around here somewhere that he's actually standing at. So you can see that's what he's colliding with. It's awesome. So it must be one of these. So that is what he should be colliding with. So now I can figure out from this, what I need to figure out is what height. So I need to actually index into this even further. Let me show. So I should be able to say, oops. Now if I do that, I should be able to print it out. So this will show how many pixels into that block that I'm in. So it should show Sonic being a couple pixels in, so a couple pixels down and 0 pixels across. Okay, so it looks like, yeah, because he starts at 96, which is like right on the border. So he's actually right here, 0, index 0, and he's at 2 pixels down. So now I need to get out the height map out of this. So height is done on the 16 by 16 block, so it's done on this thing. So there's height in here. So when you scroll down, you should see this is like the height map being printed. So this is the height map here somewhere. So I need to get out the height map for the 16 by 16 block here figure out what the height map is, and then figuring out what pixel Sonic should collide with. So it should tell me exactly which pixel Sonic should be at, or which pixel he should collide with. Cool. Okay. So I've got collision somewhere. Right. So I need to actually load up all of this stuff. Okay. Something like that, maybe? Hope this still compiles. Well, I'll have to get rid of this. Okay, layout content is not used and collision texture is not used. What was it? Collision? I thought we were using collision textures. We are using collision textures. Why is it saying not used? No, because it shadows something up here. Oh, okay. So I think that I've got a clashing name, but I think this is actually collision block textures. I think. So if this compiles, runs, and looks exactly the same, because I just deleted a function, I just wanted to bring some stuff in scope, that's all. Yep, so it looks exactly the same. Cool. Okay, so I've got my collision block textures, but what I want to actually do is, instead of collision block textures, I want to actually get the actual the data from that. Like, see how I'm rendering it into a bitmap. Rendering into a bitmap, but I want to yeah, I want to do more than that. What's defaulting here? Does that fix that? Cool. Okay. So I want to do more than that because I want to get out, instead of just texture, I actually want to get the data out. You can see the data is here. I just need to actually extract it out. This was a really good reference on the collision format. Really good. If you're interested in the collision format, read that. It's really, really good. So what should the actual data structure look like to get this out? Low collision index. Yes, that's word 8 by word 8, yeah. But I want more than word 8, I want. Can I put a link in chat? Sure thing, yeah. It is Stephen UK. Hang on, sorry. There we go, I've got it. There you go, there's the link. This Sonic Community Hacking Guide actually has got there's a couple of things in there that are really good. There's not a huge amount, but there are some things. I think I kind of used it to get some information about animation, was it maybe? There's a few good things in there. Some of the documentation is not that great, but the collision format one was actually really straightforward. It took me a little while to understand what was going on, but after I realized, I actually thought it was going to be more complicated than this. And so, yeah. That's good. I haven't actually done anything with this angle or curve stuff yet, so that's something else I need to figure out. But I have this stuff. I have all that. Okay. Hey, how's it going? Yeah. Okay. So what I might want is a maybe like a so I'm thinking maybe block collision needs to be like an array of heights. Is there anything written in Haskell or other FP language that you use every day? Yes. It depends. So for every day I use Haskell all day every day. But like I use Xmonad, which is a window manager. So I use this. At the moment, what you're seeing is not actually Xmonad, but it's very similar. Xmonad is very similar to what I'm using at the moment. But yeah, for work, I use Xmonad for everything. If you use Facebook, the spam detection's all in is all done in Haskell. I don't know if here we go. Fighting spam with Haskell. So if you use Facebook and you don't get spammed, it's because of Haskell. What else uses Haskell? Yeah, Haskell is a little framework that they've used to make it so that you can write little rules around getting spammed. So they write rules. And they use Haskell, which is, I don't know, a little framework that they use to automatically parallelize people's spam detection stuff. So that's really cool. What else? It's actually people that technically don't know. Well, they say they don't know Haskell. They're not like, they're people that come up with spam rules and that, and they've never really been taught Haskell directly. They've just been told, here's some rules, copy and paste it around and make it work, basically. So that's interesting that they've done such a good job. So that's two things off the top of my head. I know Google uses it for like build stuff, internal build stuff. Does anybody else have anything else that what's a tool that they use that's written in Haskell or something similar? I use like another popular tool is Pandoc. It's pretty cool. It lets you convert between all of these formats, so you can convert Markdown to HTML or HTML to, I don't know, to TikiWiki or, I don't know, docx. So you can usually convert like org to docx. You can do all these types of things. Oh yeah, there's Git Annex. Git Annex, which is, I think, like a Dropboxy type thing, but using Git. I think that's my understanding of it, right? Shell check, that's another good one as well. Yeah, shell check is a really good one. Shell check. So shell check lets you paste in a bash script and it tells you what your problems are with it. Here we go. You can't really see that. Here we go. So this is just a bash script, and then this is some Haskell code that goes over it, and then, I don't know, tells you all the problems with it. Echo flags are undefined. Oh, okay, cool. You can actually do things with that. Anything else? I use Xmonad, Pandoc, and shellcheck. I use all of those. I don't use Git Annex. There's also Haskell in industry or something. What about games? Not really. There's in terms of games, there's Lambda Cube. This is you can actually, it actually generates like WebGL code as well, so you can actually like so there's this thing Lambda Cube, so you can use this. I don't think there's any great examples here of like, you know, actual games or anything. But there's this thing. Anyway, this is Lambda Cube. This is like it's a 3D engine written in Haskell. So that's a really cool thing. Here we go. That actually looks like a game, doesn't it? Like a quick 3 map view in Haskell. So you can. This is pretty cool. It actually loads up Quake 3 maps and renders them. So that's really cool. That's written all in Haskell. There's Hedge Wars. Is it Hedge Wars? So this has got so Hedge Wars is like a Worms. If anyone remembers Worms, I used to love Worms. Hedge Wars is like a Worms clone, but it is well, I don't know if it's a clone, but it's basically Worms. It's basically Worms, but that's the server that you use when you play multiplayer. The server you use is written in Haskell. What else is there in terms of games? There was the Hadoom project, which was a Haskell version of Doom. I don't know if that's still going or not. I don't know if there's any screenshots even. But this was like a Doom, like... I think it was actually, was it Doom? Maybe it wasn't Doom. It was either Doom-like or it was Doom, I can't remember. Hickory. Interesting, I don't think I've seen this. Collection of tools and illustration for making interactive programs. Oh, interesting. I've not used this before, that's cool. I'll check this out after stream, that sounds cool. I'll check it out. What else? There was actually something else I was going to point out. Oh, there's Helm. Cool, I'll check that out, thanks for the link. Yeah, there's Helm, which is pretty cool. Yeah, so it makes it. So I don't know if anyone's done React or Elm. There's a really simple model which is like you have a state, and you basically have two functions. You've got something that takes like your events and the current state and then creates a new state, and then you use the state to create like your image, or like, so for React it's, you know, obviously make the HTML based on this state. For Helm here, it's create, you know, render something. So this is to render something in 2D, render the state. And so every frame you render something, and React does like a smart diffing thing, so it diffs and only makes a tiny amount of changes. I don't know if Helm actually does that or if it re-renders every frame. It might just render every frame. But yeah, it looks cool. I've not used, I think I've played around with it, but I've not really done much with it. So it looks like a cool model though. I really like it. Yeah, there's a lot of things called Helm. That's what I'm thinking of. What's this? Game programming Haskell. I've never seen this. Yeah, there is the Haskell and industry thing, but I don't know in terms of games. There's not a huge amount. I think I've listed a big chunk of what there is. I don't think there's a huge amount else. Okay, so I don't think... Yeah, okay. Don't think there's much in there. If anyone else knows anything to do with gaming and that, I'd be interested. It's actually an interesting topic. There's not a huge amount. Cool. Okay, so now instead of got this bounded array of word 16 to word 8, and I think I need to say I want the block collision now. Whoops, word A, I want block collision. Cool. Okay, I'm going in the right direction. So, what do? We need to format the collision pixel. We're getting a collision bitmap from it. Right. So instead of, anyway, we'll go with this anyway. What I want to do is get the height from each one of these. I think it's going to look something like what we had before with the rendering. Actually, that's what we want, isn't it? Heights, just heights. Okay, that's maybe word 8 with word 8. Why is it maybe? Oh, because it's meant to be like that, is it? Sorry, my alarm's going off. Maybe word 8. What is word 8? There we go. Okay. What is heights? Okay. Should be able to do that, I think. I'm just trying to get out, like, all I want to do is get like the list of, I want to get an array of how many pixels high each thing should be. And that's that. That should be that. So it's a list of word 8. Because I'm saying chunks of, here we go, chunks of. That's the problem there. So what I don't get is I've got this low collision textures, and it's taking a byte string. So that takes in the collision content. Oh, that's collision index content. Ah, see, I've got two different things, don't I? I've got collision index and I've got collision content. So I've got two different things. So one indexes it, and that's why I've got this re-index here. I see. So I've got indexes and I've got the actual content, and I need to re-index it all. Okay. So that's why I'm getting confused, because there's actually there's two different files that I need to read in. Or two different chunks of data that I need to read in. So I've got collision index, I've got indexes, and then I've got the collision blocks. Yeah. Okay. Okay. What do I do? Right, so I've actually been going in the wrong direction because that should be basically that. Okay. So what I'm trying to do is like separate out the texture loading that I've got from the actual actual reading of data. I want to separate out reading and generating textures. I'm just renaming this to be more consistent, so I stop confusing myself. There we go. It says texture, but I don't want texture. I want, what's a collision block, isn't it? Can match type collision block with bounded array of collision block. Why not? Oh, well, there is one problem here, which is that I don't actually need that M anymore. There we go. So that actually simplifies this signature a little bit as well, which is cool. Okay, so now I've got a collision block, and what I need to do is, so let this load collision texture, I should be able to give a collision block to now. And render that. So this would be collision block of heights. Something like that, maybe. I actually think that simplifies things a little bit as well. That's cool. And it compiles, I think, except for main. Main shouldn't compile, but there we go. Cool. Main doesn't compile because we need to, instead of load the textures, be collision blocks. Something like that. Compiles. Let's run it just to make sure we've got exactly the same thing. So I have made quite a few changes. So let's run it and see what happens. That is completely wrong. Okay. It's not completely wrong, actually. It's just a bit wrong. And I think the problem is, like, what I had before was, what did I have before? I had it so that it said had that may be false. I had that may be false. And so I think, like,
if it can't find the collision height, it should actually be like negative. Like it should like this thing up here should be false. And so I think that's what the problem is. So you see up here the height. If the height is greater than that, but the height, if we don't actually get a height out, it should be false. This condition should be false. So I'm gonna hack something in right now. I'm gonna hack in. I really don't like this, but I'm gonna go with this for now, just to see if this works anyway. Yeah, so I think this might work. Yeah, okay. So I do need I need this maybe in here anyway. So I'm actually gonna change this to, so say here heights needs to be a maybe height. So maybe word 8. And then down here with our heights, I'm just gonna revert what we had, which was, what did we have in here? Yeah, look more like this. So hopefully running this, we should get exactly the same thing. So before how I said it cleaned up things a bit, I don't think it actually did. I think it actually made things wrong. Okay, hopefully we've got the same thing. Cool. Okay. So we've got access to all of the collision information now. Cool. So now if I come back over, so I've got the collision blocks. Actually, where does it get re-indexed? Yeah, it gets re-indexed there. So collision block textures gets so the collision index. That's also the re-indexed collision blocks we want. There we go. Alarm was able to shut off my alarm. Okay, block index. Let's index the. Does this work? Is this what we're meant to be doing? Right, so it doesn't have collision block. I always need to get in the habit of deriving. I don't do this enough. I should be deriving that more. So hopefully I can run this and see the collision blocks. We'll see the pixels. That should be. I should see. Actually, what it should show is the heights. So the collision actually only goes up to 8. So I'm using a word 8. I probably shouldn't. But just 11, just 11, just 11, just 11. So this block here is just 11 pixels high on all of them, I think. Just 11? Cool. So I think everything's just 11 pixels high, yeah. So no matter what index I index into this through, I should get just 11 out of. Okay. I think that's right. I think the re-index, I'm indexing it by the, I think since I've re-indexed it, I can access it with the block index. I think that's right. So if I index it by pixel X, but that's what is it? Collision block. It's not exported. Actually, no, it should be like that. I just need to from integral maybe. I think that's what I need. There we go, cool. So hopefully this should show me the height that I'm meant to be at.
in that block. 11. I'm pretty sure it's 11 the whole way across, so it's not very interesting. But yeah, now if I say, so that's how high he is, and if I get the pixel y, I think it was 2 pixels down. He's in this. So he's 2 pixels down, and that's 11 pixels up. So we can actually go down another 11, take 2. Sorry, 16, take 2. So you can go down to, so he's at 14. So he's got 3 pixels difference between 11 and 14. So there's 3 pixels between him and the ground. So there you go. We've got the we've got the data there, so that we know exactly what pixel he should be on the ground. And what I'm going to do right now actually is I'm going to make him just move across a pixel probably every frame or something, just so I can see what this is. So step sprite I have. Just gonna add in here that he should, so sprite position is it? Oh no, I can just say position, can't I? Position. Can I do that? No instance of monoid. See, and I thought there was a mono for that. I thought we've been appending it before. Oh, there's a it's a number instance, isn't it? Numeric or something. There we go. So this should every frame step him across 1 pixel, and we should render that same stuff. No, he's not moving. Not moving. Thought that should move him across 1. Maybe we're actually just using this start position though, aren't we? No, we're not. Player sprite. Oh, because we're okay. So the sprite position we're not actually using. The sprite position we actually set up above. It's the game's position. Here we go. So we need to set the player position +1. Does that work? Hopefully this will work. So you can see, if you see, that's pretty cool. So this one's saying 15. So if we see 15, we should definitely like make him move up. So every time we see 15, he should jump up and jump up. But here, you should hopefully see when it comes close to here. Yeah, so it's dropping again. So now there's nothing, so there's no collision. 15, so we're actually in something. Then we're out of something. 15. So every time we see 15, we should definitely collide. Any other time, like, we actually need to calculate something. So if we see something less than 15, we actually need to calculate like how far down is it. So it's like we're 2 pixels down into the block. And so I think we can go up to, what would that be? 14 before we start colliding to it. And you see this is the actual chunk that we're, you can see here the tile is actually, the block is updating, the chunk is obviously updating as well. but this block is telling us which block we're colliding with. So we're colliding with you can see as we're scrolling across, we can see the different blocks that we're colliding with. It's really cool. Yep, now we're colliding with that. Cool. So what I'm going to probably try and do is that every time we see 15, at least, we're going to bump him up. Actually, probably should just do the whole do the actual thing that if he's colliding with something that's if he's actually colliding with something that's if he's too far into a block, he moves up to the top of the block. That's what we should do. And what we should see after we do that change, after we make this change that he actually bumps up to the top of the block, it should mean that he follows this path. So he should actually move up as he's going across here. So he should actually, you know, go upwards. We're not going to make him, we don't have gravity yet, so we're not going to make him move down, but that'll be the next step. I mean, gravity should be pretty easy to add. Gravity is just a constant thing, so we should be able to just add gravity in there. Cool. So let's have a go at that. So we've got, what do we have? We've got the heights and we're indexing so that's the height of the block. Sorry, the height of the block at that pixel. I'm not sure if that's it looks like I was actually using his the bottom right of his, well, maybe it wasn't, but it kind of looked like to me that it was using the bottom right of his sprite, but we'll see. Should be able to get a better, should really be using, I think, halfway through maybe, but maybe not. I can't remember how we're rendering him. I think it depends on that. Anyway, so that's the height. He needs to, so we've got the 16 take, where is he? Pixel X, yeah. So we need to check if that's less than the height. So I think here we can use that from maybe. What's wrong with that? Oh, I'm not spelling input properly. Okay, I'm going to print this out. So that should tell me where he should be in that. I think this is what it should say. It should tell me where he should be in this. Yeah, where he should be. Yeah, I am standing. Is this where he should be? I guess what I should probably do is calculate where he should be relative to where he is. So I should either have like a negative if I need to move him up, or I should have a positive if I'm, well, we're not going to move him down. So that's what I probably should do. Yeah, I should just calculate a difference. How should I calculate a difference? I got the height. So if he's at 2 and I don't know, 11, so that should be fine. But if he's at 2 and we're saying, I don't know, 15, then he should move up. 15, take 2. It's not 15, take 2. He should take. How many pixels should he move up? He should move up 2 pixels. Right. So we need to say. What we need to say is. He is at 10. He's at 16. Take 2. So he's at 14. So then I need to calculate the difference between there. So 14, take 15, so it should move up 1 pixel then. Sorry, 15, take, 14. Is that right? Yeah, it should move up 1 pixel. Cool, so that should be -1. Cool, so it is 16, take pixel X, that's what I've got. And then that, take the height. So I'm going to print this out and hopefully I should see a negative number most of the time when we actually get into the block. Cool. So that's something, and I'm going to just say, I'm going to cap it off so that he doesn't move downward at the moment, because I don't want to move him down. If he's not colliding with something, I don't want to move him down to where he would collide, which is what that would say. Cool. Cool. Okay. Oh wait, that's the opposite of what I wanted, isn't it? Yes, I want a min. Whoops. Okay, the opposite. So hopefully this will tell me how many pixels up he needs to move. Hopefully that's right. Maybe that's not right though. Maybe that's not right. Just because it's going 0, 1, like when he was actually in the floor, it should always be. He should always be trying to move up a whole block. I used pixel X. I just realized that was my problem. I saw it as it was going across, it was going up by 1, and that's because we're moving the pixel X, so I just realized that it's pixel Y that needs to change. There we go. So we see 0, now we see -1, so he should move up 1, that's cool. Probably, so if he moves up 1, then he'll start colliding with the block again, and so then, yeah. I don't know if we need to keep recursively checking each block as we move up. For the GUI, we are using STL. Cool. So you see this -1. Okay, so if we add that on, there we go. Let's run that. So hopefully we should see Sonic move up as he goes across. And at the moment we've only got him moving up, we don't have gravity or anything, so we should only see him move up. But hopefully we should see him move up as he goes across. Nope. Oh, because we're at 0. Maybe that's an edge case, because we're at 0, and it says we're not colliding anymore. What's the power of Haskell compared to C in your opinion? Code reuse, we've got a lot of abstraction, we've got equational reasoning. I can go through each one of those. C doesn't have a huge amount of code reuse. Haskell has a massive amount of code reuse. It's really beneficial. There is something called equational reasoning, where whenever you see an equal sign in Haskell, it actually does mean equals. So if see how I've got height here? Everywhere I have the word height, I can replace with the actual definition of it. So here and there, that's exactly the same thing. I'll always get the same answer, no matter, like, I can always inline everything. That's not quite true in C. When you see an equal sign in C, it doesn't really mean equal, it means assignment. So there's quite a bit of difference between C's equal and Haskell's equal, and the equal sign in Haskell really means equality. Which is really beneficial. So whenever it's careless refactoring. Anytime you want to refactor something and you see an equal sign, you're free to inline it, or any expression. Sorry, this expression I can move up here, and same thing. I always know that. So refactoring in Haskell is super careless. You do not have to care at all. But also, yeah, you've got abstraction and code reuse because of that. Everything kind of falls out of this property. When you've got equality, that actually means equality. Everything kind of falls out of that. And you got code reuse because you can just move everything around, and it's always equal if you've got the equal sign. Hopefully that helps. I don't know what is going on there though. Why are we getting 0? Why are we getting 0? I'm going to print out the height for each one that we're in. Pixel Y. So we're 1 pixel down. We're 1 pixel down. Height difference is 0 because we're at 15, right? Okay. It's true. I see. So if we're actually colliding with it, should we be 1 pixel above where we're colliding with it? Is that the idea, that we're meant to be 1 pixel above? Maybe. But that'll always be, yeah, that means we'll always be moving up. But I feel that's what it means, because we can't be at, if we're at the top pixel in the block, we should probably be 1 pixel above that. Maybe that's a special case. Would it be a special case? I doubt it. I guess maybe we do have to be 1 pixel above that.
I'm going to put -1, but I think that means we're just going to keep moving up and up and up. No, we're not moving up and up. So we're at 0. We're at 0 of this block. That doesn't make sense. Because we're at 0, 0. We're at 0. We're at 0 in the block. And it's 15. The height is 15. So 16, take. Oh, I see. I think this is what I actually wanted. And that's what I was saying. It's going to keep going up. It's going to keep moving up. We're always going to keep moving up. But we're not. Why aren't we moving up? It's definitely not doing what I'm expecting it to do. So pixel Y, we're at 0. So let's say if we're at 0 and our height is 15, you can see here, so 0 is our player Y, 15 is the actual block height. So we should move up to 15, that's where we should be going up to. So really what we should be getting out, what I want from here is -15, like go up, move up 15. Actually what I kind of want is actually move up 16, I think. So when you collide, I actually think I want to move up above where you've collided. So here what I'm doing is I'm saying 16 take 0, so that should be 16. So that's like how like, because we're actually at the top. When you see 0, that actually like that's from the top, and the heights are actually from the bottom. So there's a little bit going on there. But when I go 16 take 0, so I get 16. So that's how many pixels at the top I am. Like how many pixels? Sorry, how many pixels from the bottom I am? I take off 15. And so I should get 1. So that should be saying that I'm 1 from the top, which is not right really, I guess. Maybe I do want to say like height plus 1, so then I'm at 16. Yeah, maybe I want to count like that. But I would say 16 takes 16, so that's the problem there. So that's you know, that equals 0, so then I'm moving in 0 pixels. But really what I guess that's fine, but I actually want to move 1 pixel up. So I want to have it so that 16 take 16 equals move up 1. So I kind of want it to be, yeah, kind of want it to be, so it's 1 more. So maybe I should need, instead of, yeah, so maybe this 1 I've got here, this height plus 1, maybe I need to say plus 2. So 1, because it's indexed by 0. Maybe I need to do plus 2. I'm going to try plus 2, see what happens. We'll see what happens. I don't know if this is going to be the right thing, but we'll see what happens. So I've got 16. It should have 16. Then when it gets to 15, it should say 17. So it should move up 1. There we go. Wow, that's really cool. He has actually climbed up a hill just then. Cool. So if I added gravity, he'd actually, like, you know, move up and down. Okay, I'm gonna just see what happens here. I think every frame he's only gonna move up 1 block, so it'll actually take a couple of frames for him to move up, but you know, it's okay. That's awesome. So he's actually, you know, he's actually colliding and he's actually moving up. Awesome. He's gonna slide across. It might be a while before he hits anything. Slowly sliding across. Cool, I'm happy that we're colliding.
but we should collide with this next thing. Cool, so if I add a gravity in, I guess I should add just a constant gravity in, we'll see what happens. I forgot what our gravity looked like before, but let's add in how many pixels of gravity? We'll go 4 pixels of gravity. I don't know if that's actually what it's meant to be, but we'll add it in. Let's see what happens. Got stuck in the ground because we're moving up and moving down at the same rate. I see. Like like the gravity. He's trying to move up 4 pixels, but the gravity is being applied, so he's moving back down. It's interesting. Maybe if he's trying to move up, we don't add gravity. Is that reasonable? Not sure. Maybe what should happen is that gravity should be applied, then we should do the collision check and move him up, and then that would actually counteract the gravity that got added. That's probably what should be done. Also, if he's still colliding after, really that's what really should happen. If he's colliding after we move him down, he should move up again. So I actually should have like a recursive thing that actually goes through and keeps checking. You know, keeps doing this while he's colliding. That's really what should be happening. So even if gravity was applied, yeah, there's a couple of things here. So gravity should be applied first, and then should be checked, and also we should recursively check so that we move him to the right place. That's really the two things that should be happening. Okay. Gonna make a function out here that does the collision. Actually, that's what I probably should just do is play a position, modify it by collide with level. So collide with level will take the position to a position. Like that. Whoops, types. Is that right? And that's foreign.c.types. There we go. Okay, so that's getting closer. This is a little bit involved, but position. So we need to pass in the layout and the chunk blocks and the re-index collision blocks. So there's 3 things that we need to pass in. So I'm going to say unit. That's the layout, chunk blocks, and re-indexed collision blocks. And this will still give me errors and it'll tell me exactly what type it is, so I can just fill that in. Couldn't match type, list of A. Okay. So it's a list of unit. The chunk block is a bounded array. Of unit and I don't know, what was it, unit. This was actually saying that it needs to give back bounded array of chunk block. It needs to be a chunk block, does it? Hang on. Oh, it needs to be bounded array that gives back a bounded. Oh, interesting. Okay. Huh. So it's a bounded array of a chunk block. Interesting. That's not a great type, but okay. And re-indexed chunk block, re-indexed collision blocks needs to be bounded array word 16 collision block. Word 16. Okay, and give back the original thing. Cool, so from integral it'll say no number, so this probably needs to be word 18, is it? Word 8. Another word 8 maybe? I often use word 8, so I'm just guessing that that's probably what it is. And this needs to be a list of word 8 then. All of these types suck, but we're going with it. Okay. So collide with level needs to take in, what was it? What was this? Level. Oh, that was layout. Layout, chunk blocks, and re-indexed collision blocks. And we have to delete our debugging for stuff, because we don't have access to that anymore. Cool. Okay. So every frame the game will update, and at the moment the position will just stay the same. And what we're going to do is make it so it recursively updates the position whenever Sonic is colliding, and we're also going to, okay, so first thing, let's move Sonic across one every frame. So every frame Sonic will move across. That's the first change you want to make. Every frame Sonic will move to the right. Cool. Every frame is moving to the right. Cool. Every frame we want to apply gravity. So this will make it move down. Make it move down four pixels. So he's already gone off screen probably somewhere. It's too quick. Okay. And then we're going to do the collision. Okay. Oops. gravity equals that. Cool. If height difference is less than 0, then we will use the position. We'll go, that's what we want to do. We want to go with the position plus the height difference. Otherwise, stick with the position. So this should recurse now and go through every time and collide. So every time it updates his position to move up. So every time he collides, we check collision again. And looks like it is non-terminating. It's non-terminating. He's always colliding. Is that the case? He's always colliding? I'm going to make it not recurse, and we'll see if this does terminate. It should. Okay. Yeah, so he's kind of doing the right thing, but we do need to recurse, because you can see there that he was colliding, but not actually detecting, because he was moving down with gravity each time. So you can see that what I've done, I've applied gravity only once. So you got the position, move across one, add the gravity, then we do this collision check, and this should recursively, like what I had before was a recursive call, so it would keep checking. But the problem with that seemed to be that it was never terminating. It was always having a height difference less than 0. So we're always adding on a height difference, which doesn't make sense to me. I'm not sure why that was, because we should be recalculating. Oh, so here's one problem. So I'm using p. I need to use p prime everywhere. That's probably the problem. This is kind of like a case where I think shadowing is actually good. So we've got this p in scope, and if I shadowed it, then I wouldn't have that original p in scope. So I actually think shadowing is a good idea. But for some reason in Haskell in GHC it's a warning. I don't think it should be. Like, shadowing is actually a really good thing. It actually, like, when you're doing type-driven development, removing a type from scope, removing a value of a particular type in scope is actually very beneficial. So there we go, we're moving up. So we're applying gravity each frame, and then we're colliding with potentially colliding with multiple things at once, so then we move up. Cool, and we should hopefully see him move down as well now. There we go. That is not good, but yeah, that's really not good, but annoying. It goes up, moves down, moves up. Not good for the knees, exactly. I'm not sure what that's really about, but yeah. Hey Hustler, how's it going? Yeah, that's really, so what is happening there? That's interesting. I need to figure out what's going on there. So when he's going down a slope, so gravity gets applied, he moves down, then he moves up. Sonic moonwalking, yeah, exactly. I also see him bouncing around when he goes downhill for some reason. So here we actually should see him move up here somewhere. Yeah, there you go, he just appeared up the top. I mean, it's okay, like some parts of this are okay.
Going downhill though is real bad. That's really not good. What is happening there? I mean, that looks really good. See how he goes uphill? He goes uphill real good. He just does not go down very well. What's going to happen here? I guess he's going to... Yeah, he's going to go up the pipe a little bit and then, yep. Teleport. Well, we actually are using the collision map, which is a good thing. Going downhill looks bad. Going uphill looks fine. That looks pretty good. I'm happy with that. What do we need to do? Need to fix that. Definitely need to fix that. Ship it. Yeah, maybe I should make it so that you can actually control Sonic. Maybe that's something to do. So Sonic actually has like this. If you look at the Sonic physics guide, he's actually got a couple of variables to. That's how he moves around. Good enough for a screensaver? Well, maybe. We're getting there. We're getting pretty close to there. So in the Sonic 2 disassembly, we have, what do we have? Maybe it's in the constants. Doesn't. Would have thought they would have put that in the constants file, but it looks like no, they haven't put that in the constants. Well, I've lost Sonic, but yep, I've lost him. Oh, there he is. I found him. Yeah, so you can see there's a couple of different variables. There's y velocity, x velocity. So he's got like a velocity. So he's got position and velocity. So when you're holding right and when you're holding left, you're actually adding to the velocity. You're not really controlling. You're not actually saying move this many pixels to the right or move this many pixels to the left. You're actually saying add this velocity on, and then every frame you calculate velocity, and velocity is affected by a couple of different things. There's also angle information in the collision format, so that's probably something I need to take into account. There's probably like an angle where he's meant to kind of rotate around this. So he's meant to really rotate around it, and at the moment I'm kind of just going through, and then if he kind of gets stuck in here, then he moves up. I guess another thing I need to do is also, like, I've got collision with X and Y, so I've got a collision on the Y, so that if he collides with the Y, he'll kind of snap to it. There he goes, he's going to fall down forever now. So if he collides with a Y, he'll snap to it. So if he goes into the ground, he'll get stuck on, he'll move. There you go, I think that actually crashed the game. Index too large, yeah, there you go. Yeah. Still using lists in places, so that's the problem there. If I use my bounded array, he'd just be, yeah, he'd still be running. Yeah, so I've got collision on the Y format, but if I go to the right, I should actually collide with walls and stuff. So I should actually, you can see him kind of, when he was going to the right, he'd actually kind of teleport up a ramp or something. And really what I should probably do is like, see that there's a pixel on the right that's too high. I think it's like,
This Sonic physics guide does say something about how many pixels are too high. And so if it's too many pixels tall, the next tile or the next block, if the next block is too big, he shouldn't automatically move up it. Since the line is at his Y position while on steep ground, but at Sonic's X plus Y when he's on flat ground to push against low obstacles since there's no slopes to avoid pushing against. Yeah, so I should be looking to the right as well. When he's moving to the right, I should also be looking to the right and see if he should start pushing something rather than, you know, go straight into it. Because what I'm doing now is just moving him right always, and so he can move to the right and then just go into this object, and that's why it kind of teleports up things. So ideally, he wouldn't be able to do that, and he'd kind of get stuck. And then I'd have to take into consideration the curve, or the angles, yeah. So there's slopes and curves. So then I have to take into consideration that there's a slope coming up, and so we can actually kind of rotate up it. Couple of annoying bugs in the original engine because of this method. If Sonic stands on a slanted edge, one sensor will find no tile and return the height of foot level. This causes Sonic to be set in the wrong position. B sensor starts climbing down the ramp on the right, but Sonic will still defaults to the level of the previous ramp found in the A sensor. So what's this A and B sensor? I'm not sure about that. I know that there's a sensor for Y, but why is there, like, it should be X and Y sensor, not A and B sensor. What's A and B? One on Sonic's left side, the other should be on his right. Oh, okay, so you got a sensor to the right. Sorry, a sensor to the left and a sensor to the right. Interesting. Hey, do you know if it's easy to create an Android keyboard app in Haskell? If so, what's the tools that enable this? That's a really good question. There's a couple of different ways to get Haskell running on Android. There is GHC Android. Maybe this. I mean, I use Nix for everything, so I think this would, I mean, for me, this is probably what I would use. I was used against a very old version of Nix, but probably try around something like this. There should be some sort of Nix and Haskell stuff. So I'd probably look at that. I don't know if you can use, I mean, this is so that you can use Android, you can use GHC and compile it to Android, and so you'd probably be using NDK stuff, like the native Android SDK. I don't know if you, how much of NDK you can interact with the SDK. And I don't know, like, I don't know if you know anything about Android, but I know Android's got an NDK, which is the native development. So I'm sure when you're using GHC Android, you're actually mostly working with this NDK. So then you'd have to write some like Java or something to kind of cool into that Haskell stuff, which is probably not ideal. I guess most of the keyboard stuff would probably be all in the SDK, and you wouldn't have much native stuff to work with the keyboard. So basically, I think you'd be writing like a lot of Java to wrap up Haskell, and then Haskell would be doing a little bit of logic, but then a lot of the API calls and stuff would still remain in Java. So I think that would be a little bit of a problem. Will these tools compile Haskell to JVM Android native bytecode? This one, like the GHC Android that I'm pointing at, will not. And so the alternative would be this. I would look at Ada language. So this one will compile Haskell to JVM bytecode. And so I have, if you look at my blog, I've actually played around with doing this for Android. Here we go, Haskell on Android. So this is what you would write. So these are bindings to the actual Android API. And so you'd have to figure this out. This will be a little bit of work, but you'd have to basically write this code to be able to bind into however Android does keyboards. So you'd have to basically wrap it up yourself. But then you can compile it and get a jar file out, and eventually, I mean, it's a little bit of work, but eventually you can actually run Like this is actually Haskell running as JVM bytecode on Android. And so you can see I'm actually using like native widgets and that, and actually rendering that. So that works. There is, I think on the GitHub for Ada. This does not look good at small resolutions. There we go. So if you look at type lead, these are the people that are developing Ada. And if you look at, I think there's an Android example here somewhere. There is an Android one on here somewhere, I think. GHC will never be running on the JVM. So Ada basically is, Ada is a fork of GHC. It's a fork of GHC 7.10 with a couple of backports from GHC 8. So it is completely compatible with GHC 7.10. So it's GHC 7.10 with like a JVM backend. So there's basically two goals. It's basically be Haskell on the JVM, but I mean they've got a secondary goal of trying to make it, I don't know, try and make it easier for beginners that have familiarity with Java. I don't know if that's a really good goal, but this is an awesome goal. Compatibility with GHC 7.10. So this one, it's not there. I'm trying to figure out where this Android example is. Also, I will find the link. It is here somewhere. There is a link to an Android example somewhere. I think Jacinta's got it. There is it. Android. Here we go. There we go. There's two examples of Android right here. So have a look at these two repositories. This one's using Yampa, which is a functional reactive programming library, and you can see that they've actually made a game using Ada. Really cool. And this animation here somewhere. I don't know. So these will show you how to use how to use Ada or GHC, like their fork of GHC for Android. It should have all the configuration. You might be able to just clone this and modify it a bit. But yeah. Let me look at the example real quick. Okay, it says hello, and here we go. So this is the bindings that they've had to write to be able to do the animation. So you will have to write bindings to the keyboard API. I don't know. I have no idea how the Android keyboard API works, but there we go. You'll have to basically write bindings to this API. So that'll be some work that you'll have to do, but it should hopefully not be that hard. And once you do that, you can put your code up somewhere and someone else can use it as well. Cool. You should be able to do it with Ada. You could be able to probably do it with GC Android. I just imagine you'd have to, I don't know, you'd have to do a lot of work to be able to do that. Double with Gradle, hard stuff. Yep. As long as it's minimal, totally fine. Yeah. Yep. Do not like Gradle. Yep. Cool. Oops. I'm not sure what direction we need to go in. So I've got animations. I guess like guess there's a couple of things I need to do. I'm actually going to get rid of this collision, rendering the collision. Talk a bit about the specific benefits of types and type classes for your Sonic project. Yeah, sure. So I, like, my goal, at the moment I'm not using types very well at all. I'm not using them very well, but my ultimate goal is to be able to use type classes to be able to abstract away the implementation of some of this. Well, not, I guess, so at the moment you can see in my code I have like offsets. I've got this loading of offsets a lot. So I've got this offset stuff. So my ultimate goal will be so that I can actually get rid of this offset stuff. So offsets will be one implementation. So if you have a Sonic ROM, you can use this offsets. And so you can compile a version of Sonic that works with offsets, which will just load up a Sonic ROM that you have. So I've got my Sonic ROM here. That's my Sonic ROM. That's what it is. Spatial offset or memory offset. It's the offset into the memory offset into the ROM. Yeah. So it's the offset into the ROM, and it's got like the beginning and the end of like a chunk of that memory, of that read-only memory. So it goes in the ROM and it gets out like position, I don't know, OX 100 to OX 200, and yeah, we'll get those bytes out and then be able to do something with it. So it's basically just a way of getting a sequence of bytes. So that's if you're using the ROM and you want to get out a sequence of bytes from the ROM. I would like to be able to make a version of Sonic that people have supplied images for, and so it doesn't have to go into the ROM. So for example, like if I got someone to make some pixel images for me, some like, you know, I forgot what you call it, pixel art. So I get someone to use pixel art and make up some images for me. I should be able to say, here's a version of Sonic that doesn't use this ROM. Instead, it uses some files from the file system. So, I mean, really what I could do is use a type class. Instead of saying the type class that has... So I've got this has_ROM thing. So instead of saying has_ROM, I should be able to say something more generic here. So I've got this decompressed file, and I've got this has_ROM. This kind of sucks. What I should be able to do is say, instead of has_ROM, I should be able to say like has level loader or something, and then I can load up levels. So I can say like load up the first level or load up the second level. I shouldn't have to say like, you know, it has a ROM, let me get this offset and whatever. So ideally I'll be able to abstract away this sort of stuff. At the moment I'm not doing a good job. I'm just saying, you know, it has a ROM. The game has a ROM, and I can load up the game and I can get the ROM out. And what I want to go is more in the direction of abstracting away the actual concepts that Sonic has. So Sonic has the idea of a level, Sonic has the idea of the sprites, it has the idea of collision maps, and so I should be able to say load collision map, load level, load this sprite, and it should go off and load it up based on. So you should be able to instantiate your own type classes and say this is how I load Sonic, and so you can replace Sonic with, I don't know, Supersonic all the time. So you can actually, instead of like, so if I had a class saying class has Sonic, so my game has the idea of Sonic, and I can say load Sonic, I don't know what it would be, like G2, I don't know, some sort of Sonic mapping, or like some sort of sprite mapping or something, I don't know. So it should be basically things like that, and then I can say instance has Sonic for my version of Sonic, which has Sonic as Supersonic. Like, I should be able to do something like that. Should be able to do something like that. So if you want to have Sonic that's always supersonic, there you go. You write that instance, you're done. That is my ultimate goal. I don't know how I don't know how well I'll be able to do that, but that is the ultimate goal, and I think that will demonstrate, you know, the power of taking something that's, you know, formerly like low level, and being able to convert it into Haskell, and then be able to use the benefits of Haskell, being able to use types and abstraction to be able to improve the ability to work on that old game. And that's where I want to push. I mean, types by itself are kind of helping me out get into the right, like, you know, I should be using types a lot better than what I am at the moment. I'm using lists a lot, and I'm indexing into lists, and so I made a massive mess. But as I clean things up, types will help me a lot more. And in the end, my end goal is to not only have clean types to be able to implement this, but also be able to use abstraction to be able to allow people to either make their own game, or I should be able to, like, I really, what sucks at the moment is that people, if they want to run it, they have to get this ROM. They have to get a ROM to be able to play this game at the moment, and it would be cool if it works for this ROM, but also it would work with what, I don't know, if someone wanted to make some art for the game, I should better load up that art and be able to use that. I don't use Hacker News, so I'm not posting it to Hacker News, but I will eventually write up something once I've got something somewhat working. I will do that. Okay, what should I do? Standing, pushing. So I've got the standing animation. I could add, like, maybe I should start working on walking animation. The walking animation is a little bit tricky because it's actually custom. There's actually, so like, if you remember back to when we did animation, the first part of an animation, this part, the word 8. So an animation is, you know, it's a word 8 followed by animation steps, and that word 8 is meant to represent how many frames to wait between each frame, like how many actual, like, game frames to wait between each frame of the animation. So each step is processed every whatever frame. So this could be 5 frames, or it goes up to 255. So 255 frames, it could be up to 255 frames, but there's actually, like, and that's what, if you look at the walking animation, it actually says every 255 frames process the next step. And so I was looking at that going, that's got to be wrong, but it turns out that's the actual wait is ignored, and it's actually like a special thing. So it says that the walking animation takes 255 frames in between each of these steps. But that's not quite right. It actually, if you look at how Sonic walks, it's actually based on on his velocity. So it's actually some custom logic in there, which is like the wait time between frames is actually how quick you're going. So if you're walking slowly, the frames get, like, the time between frames is actually a lot. So it's like if you start walking fast, the time before frames is like is quite slow. So it's actually like it's actually variable based on how fast you're walking is this delay. So that's interesting, and I don't know how hard it will be, but also, like, you're walking, but then you could process into running as well. So there's actually like you actually have like you have to actually change the animation between different velocities. So that's a little bit tricky. I don't know if I'll be able to, if I want to work on that right now, because it is a little bit involved. Maybe we could do that. Maybe I should add the velocity, start working on velocities rather than, oh, here we go. Sonic with simple platform require nothing but blocks. You'd only need 2 variables, x and y speed, acceleration, deceleration, friction, gravity. So gravity, when Sonic is in the air, interesting. Jump velocity and gravity are added to whatever when Sonic is in the air. Maybe that's part of my problem. Maybe I only need to add gravity when Sonic is in the air. So I wonder how he sticks to the ground though when you're moving up and down. How does he stick to the ground? Is that covered in this? But when slopes are involved, while Sonic moves along the slope, he's moving both horizontally and vertically. That means that both x and y have a non-zero value. Simply adding acceleration, deceleration, or friction to x no longer works. Oh, right, because you can go up slopes. Okay, cool. Imagine Sonic was running up a wall. Adding this to his horizontal speed would be useless because he needs to move upwards. Ground speed. I mean, what I should really be doing is like adding these variables into Sonic. So the player should have all of these things I was talking about. X speed, Y speed, velocity, friction, all that sort of stuff. Okay.
While on the ground, x speed and y speed are derived from ground speed every step. Okay. Ground speed times cos angle. So that's the angle he's at. Sine angle. Still need to be slow when going uphill, speed up when he goes downhill. Yeah. Slope factor. Slope factor is always that. But not when running. Ah, interesting. When Sonic is going uphill, slope is that. When Sonic is going downhill, slope gets faster. So it basically almost triples actually. Jumping. Falling, air state. So I guess like air state would be useful to do, but I feel like I want to start working on actually specifying these variables that he's meant to have. Gravity. I'm interested in like the gravity stuff because my gravity is obviously a bit broken. But what I want to do is, now I've got this player, I want to specify some things about the player. Do you know if the original game was coded in assembly language or was it high level C? From what I can tell, it was coded straight using assembly. I think it was basically coded like this. I don't think it would have been encoded in something like C. I don't think so. I'm not confident, but I don't think even back then there was really anything. I think everything back then was coded in assembly. I don't think anything back then was coded in C for the Mega Drive. I don't think there were any games. Majority of Sega Mega Drives were written in assembly language. A select few. Sonic Spins Ball was written in C. There you go. Assembly is boring and a waste of time. I agree. That's what you had to do back then. We've got better tools now. There you go. I think that's basically true. Yeah, Mega Drive games were written in assembly language. Pretty much all of them. I didn't know that Sonic Spinball was actually written in C though. That's interesting. I don't know if anyone else remembers Sonic Spinball, but that was an interesting game. If we can have high-level code with low-level performance, wouldn't even toy with the idea of writing assembly or C. Yeah. I completely agree, and that's why I don't write C. All this mess that I have to use... It's all this mess that I have to use Rust, which is ugly but good. Okay. I don't... A lot of people write Rust at work, and I don't understand it. Like the only thing I'd probably use Rust for is writing a garbage collector, so I don't understand why people write Rust other than writing garbage collectors, honestly. So I'm going to add velocity and friction. Acceleration. For crypto? Oh, okay, maybe, yeah. What they're using for? I don't know, random things like... there's part of Bitbucket. Part of Bitbucket is written in Rust. I think it's like the code search or the... I think it's like the code search or something is written in Rust. And I really don't get it. I just don't understand that sort of stuff. Acceleration is what?
Understand robotics or something? Yeah, not code set. I mean, I'm not criticizing them or anything, but I just don't understand it. Top speed. Okay. So what do we have? We've got position. What was the second one that I added? You'd wager what outperforms Haskell on most tasks? Radius, X radius and Y radius. Is that what I added? Maybe I added that, but I don't think we're using it, are we? If I deleted this, will anything, I mean, other than that. Okay, that 13 is, I see, that is the, that's the radius to look at, I see. So that's why I saw those weird 13s over here somewhere. Skeptic eyes, exactly. That's where this is coming from. That's where it's coming from, okay. And what was that again? That is the radius. So less about outperforming, more about not having to work with garbage collection. Garbage collection is a non-starter for most hard real-time systems. Yeah, okay. Cool. Radius. I just don't, a lot of people are using Rust and I just don't understand. I don't get it. Why I'm using Haskell records for the player? I don't use records in Haskell. That's why. Yeah, it would be even easier if I did something like this. It would be easier if it was named, but I don't do that. I use lens for everything. I don't use Haskell records. So this makes it even easier. Because that's not position, it is radius. Haskell records, you know, are really super. You can make lenses from records, but I don't even, like, I mean, the records, I don't get any benefit from doing this, for example. I don't, like, this is completely deficient in pretty much every way. There is no, what benefit do I get from this? And the answer is nothing. I mean, I've been doing Haskell long enough to know that I get no benefit from, like, that. This thing is just not useful. Records are just not useful in Haskell. Lenses are super useful. If I've got lenses, I'll use lenses. It doesn't make sense. I just don't have any real reason to use records. This is better documentation. This is far better documentation than the record. Game. Basically as useful as a comment, exactly. I could leave a comment there, but I don't even need to because I've got this. This is how I define lenses. This is how I define them. I sometimes use things like, what is it, make lenses, or whatever you have to do to make lenses. Or it's make lenses player, like that. Something like that. I sometimes do that, but I prefer to have everything explicit. Bouncing around, okay, anyway. Make lenses, is it make lenses player? So, I don't know, there's the template Haskell. I sometimes use that, but yeah, I need to have some tooling so I can actually just write that and then have it dump out this code. Yeah, like I don't like typing out this code, but really what we need is yeah, we need some integration to be able to work around that. Yeah, we've got flowers and trees and stuff. Yep, got it all. It's all there. And Sonic actually does move around the level. He moves around a bit weird in some places. When he goes downhill, it's all super weird. But he does move around. You can see him moving up this hill, which is good. And this is looking really good, except it's just when he goes downhill. You should have a look at when he goes downhill. It looks a bit weird. I don't know why he's bouncing up and down, but it looks like here that he's not really meant to be. I don't know. It looks like gravity might not be applied all the time based on what I'm reading here, but I'm not confident about that. It seems like gravity might, like, probably should be added. I don't know. It doesn't sound right, but it does say something like if he's in the air, then we apply gravity. But I don't know. I feel like we should be applying gravity all the time. Wondering whether flowers and trees were referring to some sort of obscure functional data structure. Well, we've got rose trees. That's a flower and a tree. Got rose trees. There you go. Oh, maybe make lenses does need record field access to be defined. You might be right about that. I think you're actually right. Yeah, that's a really good point. Okay, so we're adding on that radius now. So that's actually, so that radius is the radius to look at up and down to be able to figure out sorry, I guess it's just down at the moment that we're using it for, but it's the radius that we're meant to look in to be able to figure out to do collision detection. And so we've got the position and we've got the radius. And so I think velocity would be another thing to add on. X and Y velocity. What's this sub? I don't know what this sub is. X sub and Y sub. Subpixel position. Subpixel position. Then you can be part of a pixel through, is that what it's saying? Subpixel would be part of a pixel? I don't know. Subpixel position. Puff and Sonic. Paths, trees, and flowers. Oh, is that actually... That is actually a paper? Interesting. Paths, trees, and flowers. Huh. Oh, graph theory. Oh, interesting. Okay. What's the flowers part? Is there actually a flowers part, or is that just meant to be a pun? Okay, I'm going to ignore the sub thing, but we are going to put in x velocity and y velocity. It looks like actually velocity is meant to be a decimal, wasn't it? If I'm looking at this. There's also speed. Is that what it's calling velocity? Might be ground. Is it ground velocity? Yeah, ground speed. Trying to figure out where the ground speed is specified. Directionless representation of speed. Maybe that's okay. Not updating the S. That's probably what they mean by ground speed inertia. Inertia. Okay. Okay, so the player's got inertia in it. I don't know what that, if it's meant to be a double or not. So inertia, and then we've got x velocity and y velocity. Yeah, cool. I'll add that in as well. Don't know, type level literals without prime, turns out that's only if you use wanting all. Yeah. I use wanting all for everything though, so I would leave it, like, yeah, I would use the prime. There we go. Need to sub X and Y to smooth out those occasional bumps. Maybe. I think actually more of the direction for the bumps is this slope factor. If you're going downhill, I think there's some sort of sloping that I'm meant to be applying or something like that. But I'm not sure. I know that will definitely help with this. But I think, so you can see here, like, you're meant to kind of like curve down, like it kind of curves. Each one of these is kind of like got a curve, so then something goes around the curve. But each of these blocks has got a curve on it. So what this is saying is saying like there's a curve from here until there, and there's a curve. So there's all these, there's like these slopes. So Sonic is going up a slope here, and so as you're going up a slope, Sonic actually kind of turns with the slope. He actually, like, you can see here that he's on an angle. So he actually goes with the angle that is specified in these blocks. And so I have a feeling that if we're going downhill, he's actually kind of meant to go. He's kind of meant to go down in that direction, maybe. I'm not sure, but I feel like he might be able to go in that direction, and so that might be the thing. It doesn't make much sense, I guess, if he's going to the right and he keeps bumping up. I don't know why. I guess what's happening. Right, I see. I realize what's happening. Right, so he's going across, and we're actually going to the block below. And so Sonic is kind of, but he's still moving. So when he's moving across, he actually looks like he's going up, doesn't he? He actually does look like he's moving upward. So I guess there is something still going on there. So we don't have an air state, that's okay. But we do have this x velocity, y velocity, and we've got the position. So this is position, velocity, radius to look in, and then inertia. Inertia is here called ground speed. So then his speed is ground speed by the angle. Ground speed by the sign for his y speed. But I guess where's his velocity get incorporated into this though? So x gets added to, so x speed gets added to his x, y speed gets added to his y. Where's acceleration and deceleration come into it? Trick is to apply a third speed variable, and let's call it ground speed. This is the speed of Sonic along the ground, disregarding the angle altogether. Acceleration, deceleration, and what's FRC? Friction. Acceleration, deceleration, and friction are applied to ground speed. I see, okay. So his x and y, these are added based on the ground speed, and ground speed is calculated, so the inertia is calculated based on acceleration, deceleration, and friction. So every frame we change the ground speed, and then based on the ground speed, we modify the x speed and y speed. So for this, we'll just have, oh, good luck with your interviews. Hopefully your interviews go well. Programming interviews are the worst? Absolutely, 100% agree. No programmer can interview anyone else, but they always try. I think the first step is to recognize that no one is good at interviewing programmers. Usually spend time unemployed to not go through them. Well, that's one solution, I guess. That is one solution. I had to review almost 100 different applicants to one of our roles recently, so yeah. So yeah, it's not fun. Good luck. So for our first version, x speed will be just the ground speed. They'll be the same thing, because this will be cos 0, and cos 0 is 1, right? Well, not cons, too much functional programming. Cos 0 is 1, awesome. And negative sine 0, so sine 0 is 0. Cool. So that'll be ground speed times 0, so negative 0. And this is, times 1. So for our version, because we're just moving to the right, it'll just be 1. It'll just be the ground speed, which makes sense. So we've got this inertia. Inertia is, so every frame we add the inertia on to x. Question, what animal would you like to be in 5 years? Typical programming question. And that sounds, it's not far off. It's not far off. Okay.
acceleration, deceleration, friction are added to x speed, jump velocity and gravity are added to y speed when Sonic is in the air. That's the interesting thing. Like when Sonic is in the air, then we add gravity. When Sonic is in the air. So do we not usually have gravity? I wonder if that's a... Apply gravity. Seems like in this main function, which I think is... Oh, that's a masher. Ah, okay. Tails, it's got gravity. Sonic. MD jump, I'm guessing mid jump or something like that. Mid-air. Maybe, you know what, actually it might look like that Sonic only gets gravity when he's in the air. That actually might be a thing. So when he's jumping we reduce gravity. Oh, that's when we're reducing gravity and when we're in air. Would it be better if job applicant got a programming problem to be done over a few days, then talk about the decisions and thought process during interview? It would be, but I mean, not everyone has time for that. As long as it's not too intensive, like to be done over a few days. Like I mean, as long as they can spend maybe like an hour on it a night or something for a few nights, or like, and I probably wouldn't even limit to a few days. Like give people some time. Like things, they might be able to come into an office for a couple of hours, but they might not be able to, you know, be able to allocate a couple of hours to spend on it over a few nights or something. So I don't know. Like, I don't really like a lot of that take-home stuff because people are busy. People have things to do. And so I wouldn't try and get them to do any more work than what would be required to come in for an interview anyway. If you know what I mean. But I do think that is like a better way to kind of, I don't know, be able to determine people's abilities maybe. It's really hard to determine things though. It's super hard. So this is object full. Object movement full. Okay. So when Sonic is in the air, we do this. This is one of the first things we do when Sonic is in the air. Go to jump height, change jump direction, level bound, and then we jump into this subroutine. Okay, when Sonic is jumping or when Sonic's dead, or mid-jump, yeah, so I think that's basically it. Object 1, yeah. So object full is called when Sonic is in the air, and that's when we apply gravity. So it looks like it might be the case, like what this is saying, which is saying that when Sonic is in the air, we add gravity to y speed. That might be true. That might actually be true. Anyway. We'll keep going on with this. So we've got the position, velocity, radius, and inertia. So we need to calculate inertia by... What is the algorithm for inertia? So it's when he's on an oil slide. Sonic start running, clear inertia. Maybe the applicant gets to share some code they've already written and talk about it during the interview. Yeah, that's okay too. I mean, I guess the other downside to that is that not everyone has code to share. So a lot of people work you know, in companies that, you know, they wouldn't be able to take their code with them or be able to demonstrate it like that. Like, especially, I mean, like especially since there's quite a few good people that work with like verification in like military-ish settings. So like, you know, they might have a contract with, I don't know, DARPA or something, and they might not be able to show their code. I'm just thinking like things like there's companies like Gawa where they've got a lot of good people, but you know they do a lot of contract work for DARPA and things, so they probably wouldn't be able to demonstrate what they've written because it would all be very private. I imagine a lot of companies are like that. Like if you ask me, like, show me some code you've written, I'd be able to show you the Sonic thing, but I mean that's because I've got enough time to be able to show that sort of stuff. I've got enough time to spend on writing Sonic in Haskell. There was Sonic Walk, wasn't it? Sonic Walk is probably more like the... Here we go, Sonic Walk speed, maybe that's what we want. Subroutine to calculate how much space is in front of Sonic or Tails on the ground. What? Oh, it's calculating. Oh, that's not what I was thinking. Yeah, open source contributions are pretty good to talk about, but not everyone has got that, so I don't know. Wouldn't you be skeptic about a developer that doesn't have a single project on GitHub? No, I wouldn't be skeptic at all. I just reviewed 100 different applicants to a job, and that was not... I didn't look at any of the GitHubs. Well, I mean, I did. If they linked to it, I'd have a look, but I didn't mark them down for not. And really, when I was looking at it, it was just like, do you have a skill that would be immediately useful to us? Because we need someone soon, basically. And so it's like, do you have skills that I'll have to teach you, or do you... like, do you have skills that otherwise I'd have to teach you or not? And that's basically it. So that's all I was trying to measure through GitHub, and it's not, you know, it's not a great indicator, but it was one that I was using. And if anyone had like any, you know, if in their resume they mentioned any of the technologies that they'd ever worked with it, that was a mark to move on with them. And that's basically it. We're trying to get someone that we're trying to get some people that we're not trying to, that we don't have to. We're gonna have to train them in a way, but trying to get people that have some experience with the tools that we use. Just that we have to train a little bit less at the moment, just because we're in a massive rush. Otherwise, I don't mind training people at all. So, I mean, if we weren't in a massive rush at work, I'd be happy to hire pretty much anyone that you know, seems like they can write code. So, anyone that's willing to learn, I'm willing to teach. Was Haskell a requirement? It's not a requirement, but it's a benefit, because we do have Haskell in production. So it's like we're trying to get people to come in and work on production very soon. And so if you have Haskell experience, that's a plus, not a requirement, but it's a big plus. And also Scala is kind of like, there's nothing really that's a hard requirement. So like if you already know Scala and you already know Haskell, that'll be a benefit to our team. And that's basically it. Trying to figure out, so we've got the acceleration and deceleration and the top speed. I guess that's something else we need to bring in, top speed. What sort of projects does the company you work at do? We make software for teams, so collaboration software. So we make, I mean, you've probably heard of this, Jira. We make Jira, Confluence, things like Trello, Bitbucket, SourceTree, basically things that you use to collaborate with your team to be able to do things. We've got Stride, which is a chat application. So basically software for teams. And usually, like, previously our focus has been on software. I mean, we're expanding out to more things. But yeah, software is kind of like our main core kind of thing at the moment. Things that we have a lot of breakthrough with. Jira is not Haskell based, no, but I work on Marketplace. So I work on this part, which is just like an app store for all of our products. So it is like an app store for Jira. So if you need a plugin for Jira or you need something like that, you can use Marketplace, which is not Haskell. Like, there's a percentage of it that is Haskell. It's a very small percentage, and it's not an important percentage, but it is. We do have Haskell in production. It is in there in production. It's just not very important production software. Most of this is written in Scala and Scala Z. So it's actually like, it is almost completely purely functional. It is like, it's the most, like, the thing with Scala is that it's extremely hard to be functional, and so people will accidentally, they'll import a time library. Their time library will accidentally, start reading from the system time, and so then your function isn't actually a function. That's rare, but it has happened inside of Marketplace. So I don't want to say it's completely functional, because it's quite possible that like there's something here that's been accidentally imported and is doing some side effect. It's very hard to verify that something is actually functional in Scala, just because there's so much. But it's mostly functional. It's definitely the most functional Scala code I've worked with. Seen the Atlassian name from logging into Bitbucket. Heard you talk about Atlassian, but someone didn't make the connection. Oh, yep. That's the connection. I work at Atlassian. Atlassian is Australia's biggest software product company. By far. So I'm not saying it's Australia's biggest software company, because I think there's like, there's IBM or something like that, which is probably bigger in that, but they do consulting and that. We're the biggest product. We make the biggest, software product. So there's I think we've got like about 1,000 people in Sydney. So it's, if you hear an Australian, like all Australians know about Atlassian because it's like Atlassian is our biggest company, biggest software company. My team though is in San Francisco, so this Marketplace, like all the rest, like I'm the only Australian that actually works. Well, I'm not the only Australian that works on it. I'm the only Australian in Australia that works on Marketplace. I'm the only person in Australia that actually works on Marketplace. Yeah, they've got. I think we're actually moving offices in San Francisco. They're moving to some other office or something. I think San Francisco is maybe our second biggest office. I'm not sure. It's either second or third. It's pretty big. It must be the second. It's pretty big. So I've got inertia, top speed. I'm not sure what the top speed is meant to be for. I wonder what this top speed is meant to be about. Your friend works in Austin? Yeah, Austin's another, that probably is our third biggest office, maybe. Yeah. San Francisco, Austin, Sydney, those are the big ones. There's also Mountain View now. And we have just announced a Bengaluru office. And that's what I was reviewing resumes for. The Bengaluru office. We're just opening that one up now. People will be hiring in the next couple of months. Not sure where this top speed is meant to be come from. Okay, here we go. So when he's in water, okay, so it depends on if he's in water or not. So if he's in water, we set the top speed. And top speed is also set by if you're supersonic, or if you got the shoes on, you know, those fast shoes. Okay, so that's Sonic's top speed here. So that's no, this is the net. So this is like, you know, the initial. So I want it to be that by default. Okay, OX 600, and I want to do that into a double. Can I do that? Is it a double? Is top speed a double? Okay, acceleration and deceleration. So those are two other variables I need to put in as well, don't I? Acceleration and deceleration. Okay, well, I feel like that might be a float. Is it a float? It might be a float. And this probably doesn't compile because I haven't set all those other things yet. Okay. So what was it? It was position. That's position, and then I had acceleration, didn't I? Do these chips have double precision floating point numbers? No, they're only single precision. So when I'm saying double, I actually mean float. That's why I should be using floats instead of doubles. Yeah, they didn't. And velocity 0, 0. Gonna go with that for now. So here I should be able to use float. I don't have to import float, do I? No. Don't see float very often anymore, do you? So position, velocity, got radius there, top speed 0, inertia 0. I'm gonna get this to compile, and then I'm gonna call it so double wherever. There we go, float. Okay. We're starting to put the variables in for the player. We've got him colliding with the ground. Float's making a bit of a comeback with deep learning, maybe? Oh, okay, maybe. Lower VRAM requirements. Yeah, that's okay. That's a good point. Okay, well, I'm happy with him colliding with the ground there. I'm not happy with him colliding with the ground on this side. I don't know why. Oh, I think I know why, but see, it looks like he's actually moving up, and that's what's bothering me, because he shouldn't move up. You know, every time he goes to move down, he actually looks like he goes up. And so what I can understand is if he goes across and then he goes down, across, down, across, down, across, down. But it looks like he's actually going across, up, down, across, up, down, across, up, down. That's what I'm not sure. You happy with the flowers? Awesome. Got some flowers in there. And these are actually meant to be animated flowers, and so that's something else I have to get working as well. Animated flowers in here. But yeah, I'm not happy with him going. It looks like to me that he's going up and then down. He's going across, up, down, across, up, down, across, up, down. That doesn't make sense to me. Otherwise, it looks pretty good. I'm happy otherwise. Like, it really, yeah, he's going. It looks like he's going up to me. It really does. So I think he's going up, and that is the bug. I'm not sure why that is happening. I can understand if he's going across and down, because if he goes across, then he's not colliding and apply gravity. Go across, not colliding and apply gravity. But yeah, I don't understand why that's happening. And really, because we're applying gravity every frame, I feel like he should be like, if he's going across, he should basically be he should go across, down, get stuck in the ground, then come back up to where he should be. So really, he should, like, it seems to me, he should be sticking really close to the ground. And so he shouldn't be, you know, even though I would understand him going across and down, across and down, across, down, I think the logic from my understanding is that he should be going down like that. He should just be following this completely fine, because he should be going across 1 pixel, go down into the ground, come back up, and then be aligned completely up. So I feel like he should be, could be an optical illusion that it looks like he's moving up. It could be, yeah. You might be right. It could be, yeah. But still, he should be. I will maybe load the Y position. Exactly, I will do that. But I've run out of time today. I've got a meeting soon, so I have to go.
But I guess next time, that's what we'll do. We'll try and debug why he's not staying right on the ground. Should stick to it. He should. So I'll log out the Y position, figure out what's going on, and we'll figure it out. Hopefully the Y position will not say that he's going up and it is just an optical illusion. Hopefully that's the case. Cool. Well, I'll commit this and I'll push it, and let's find out someone else to stream. So if you look on Twitch, there's the functional community that I created a while ago. Awesome. Glad that it's fun. Okay, so there's someone who's doing Haskell. Awesome. There you go. So if you look at the functional community, sometimes there's some good stuff in here. You can also press the follow button on it, and then when you go to browse, it'll actually come up down the bottom. It'll say the functional community, so you can click on it easily. So we're going to host Cyrus T. Crumples. Cyrus T. Crumples. Interesting name. As usual, people have got interesting Twitch names. Is type level programming in Haskell as painful as it seems? I've been playing around with the usual type level natural numbers and Fibonacci, and even just trying to construct the 20th Fibonacci number takes a ridiculous amount of RAM. Does Idris or type level programming in general suffer from this, or did I just muck something up? Idris will do a little bit better, but Idris has also got its natural numbers are also like it's interesting. Get Soding on there? Yeah, Soding is cool. Shout out to Soding. He's got some good stuff. Look at his videos if you're interested. Just as a detour, look at if you're new to Haskell, look at this guy on YouTube, and he's uploaded some recent videos of him working through some simple Haskell problems. Well, it's Haskell for JavaScript programmers, but look at Haskell Rank 1 and Haskell Rank 2. Those are good videos. You can check them out. But to answer the question around type level programming, is it as painful as it seems? Yes. It is slow to compute natural numbers at the type level. That is very true. Idris does a little bit better, but Idris also represents natural numbers. Idris has kind of got two different phases. It's got you can have natural numbers which will generate, which will actually become arbitrary precision integers, which are a bit faster to work with. I'm not sure at what point Idris will use those though. I'm not sure, like, because there's kind of like a couple of phases that Idris goes through. It's got an interpreter, and it's got like a C backend, and so the C backend I know uses libgmp, which is the arbitrary precision integers integer library. And so if you are trying to compute natural numbers at runtime, it will be a bit faster, even though the thing with Idris is you don't have a separation between the term level and type level. They're the same thing. You've got like a hierarchy, but they're really the same language. So if you write natural numbers at the term level and you go to use them, it'll actually get optimized, and so you'll actually have fast natural numbers when you go to run them. I mean, they're not. When I say fast, it's kind of fast. It's not, it's not super fast, but it's, it's fast enough. So to compute Fibonacci would actually be pretty good. I'm just not sure if when it goes to compute types, I think it might use its interpreter, which will be a bit slower. Now, I think it will still be faster than Haskell. It'll still be faster than GHC. So try Idris, try and do the Fibonacci. It'll be a lot simpler. Like if you've done it in Haskell, it'll take 2 seconds for you to do in Idris. So I'd try it out in Idris, but I have a feeling that Idris actually uses the interpreter when it goes to compute type level things. So when you actually go to type check, it'll actually use the interpreter. When you go to execute it, if you go to execute Fibonacci at runtime, if you actually compile it into a program and run it, it'll go a bit faster. Well, go a lot faster, because there's the separation between the interpreter and the runtime. So the runtime actually uses libgmp, which is an arbitrary precision, makes it a bit faster. When you go to interpret it at the type level, I think it'll be a bit slower, but it'll still be faster than Haskell. So I think you're going to have 3 different levels of performance there. You're going to have Haskell at the type level, which will be slow, Idris at the type level, which will be a bit faster, and then Idris at the runtime, which will be even faster. But the thing with Idris at type level and runtime, there'll be this exact same code. If you write Fibonacci in Idris, you only have to write it once. Unlike in Haskell, where you have to write it one at the type level and one at the term level. But anyway, hope that answers the question. I've completely run out of time, so I will host this person. Thanks everyone for joining in. Actually, I'm going to start raiding. Supposedly raid is a good way to do it, so I'm going to raid this person. I've never done that before, so let me know if this is not a good thing to do. But I'm going to raid Cyrus T. Crumple. Say hi to them, and I'll see you. Actually, before I go, I should say that next week I'm going to be at Lambda Jam, so I won't be able to stream next week. Well, at least not on Monday. I'm going to think about what I can do. Maybe I can do a little bit later in the week. I don't know. But next Monday I will be at Lambda Jam doing a presentation about teaching Haskell at Atlassian. So I won't be able to stream then. but I'll try and stream some other time next week. Okay, I really have to go. I'm hosting this person. I'll see you soon. Not sure when. Cool. Thanks everyone for joining in.